Okay, welcome back, ladies. Today we're going to be looking at a review of some vocabulary and then starting in on some new types of problems. Today we're just going to do one example, which is going to be a centroid, okay? And that'll be question number 1 for the worksheet that is online. But first we have to go over a lot of review, some different vocabulary to make sure we remember what they all mean. A median, remember a median is in a triangle, and it's a line that connects a midpoint, so a midpoint would be down here, to the opposite vertex. So it comes from a corner and then hits a midpoint. So if I had the coordinates of the vertex and the coordinates of the midpoint, I could find the equation of that line. Perpendicular bisector is a line perpendicular to a side that goes through the midpoint of the line. So it goes through a midpoint, so that's my point, and then I can find the perpendicular slope in order to use a point slope form in order to find the equation of my line. Altitude comes from the point and makes a perpendicular to the other side. So whereas a perpendicular bisector goes through the midpoint and is perpendicular, this one goes through the vertex and is perpendicular. So I would use this point, the vertex, with my perpendicular slope in order to find my line. And centroids, remember we had some centers of triangles. A centroid is the point where 3 medians cross. A circumcenter is a point where 3 perpendicular bisectors cross. And an orthocenter is the place where 3 altitudes cross. Okay, so we have all 6 vocab words: the median, perpendicular bisector, altitude, centroid, circumcenter, and orthocenter. Okay, so that's all of our vocab that we need to know. If you need to take a minute to write it down, go ahead and pause the video, okay, copy it down, and then continue on. Okay, the next thing we're going to look at are some steps, okay? So the first set of steps we're going to look at are the steps for a centroid, okay? If I want to find a centroid, the actual exact point for a centroid, the first thing I'm going to do is find the midpoint of 2 of the sides. It doesn't matter which 2 sides you choose, but sometimes there are some sides that are a little bit easier. If there's a side that's along an axis, that would be a good side to use. If there's a side that has one of the vertices at 0, 0, that's a good one to use. Try to use the ones with the fewest negatives, okay, and ones that have the most zeros. Those will be the ones that make your life the easiest. So our second step is to find the equation of the line that connects the midpoint and the opposite vertex. Okay, when you're looking at your midpoint, when you find your midpoint, it's easy to locate the opposite vertex because it is the only point you did not use when you were calculating the midpoint. Okay, so if you use A and B to find your midpoint, then C is the opposite vertex. If you use C and A to find your midpoint, B is the opposite vertex. Okay, so it's the one you do not use to calculate the midpoint. So we find our equation. Again, we use that point slope form that we reviewed in the previous video. Y minus y1 equals m times x minus x1. And then, once we have both equations set y equals, okay, we set them equal to each other and solve the system to find x and then the intersection point. So it's a 3-step process. We're doing 3 things that we already know how to do. We just have to put them all together to find some more difficult answers. Okay. The next thing we're going to look at is the steps to find a circumcenter. Okay. For a circumcenter, the first thing you want to do, remember circumcenter is the perpendicular bisectors, so it's perpendicular to a side and it goes through the midpoint of that side. So it's perpendicular to the same side that it goes through the midpoint. So we find the midpoint, the first 2 steps, the midpoint and the slope of the same 2 sides. Make sure that it's the same 2 sides. You can't use 2 sides for one, like A, B, B, C, and then AC for the second step. That would be bad. So make sure you use the same 2 sides for the midpoint and the slopes. The third step is to use the slope from step 2 to find the slope that would be perpendicular to the side. So we take the slope from 2 and find the negative reciprocal. Okay, so step 3 is pretty short. You just take your slope and you flip it over and change the sign. For step 4, we use the midpoint from step 1 and the slope from step 3 in order to write an equation. So that's using your point slope form. You have the point from step 1, slope from step 3, and we plug it in just like we did in the example on the previous video. And just like the centroid, you go ahead and set the two y's equal to each other and solve to find the x and then the intersection point. Our last center from a triangle is the orthocenter. The orthocenter also uses perpendiculars, okay? So first thing we do is we find the slope of two sides. There are no midpoints in orthocenters, okay? So we just find the slope of two sides of the triangle. We flip it over and find our negative reciprocal for step 2. And then we find the equation of the line using the slope from 2 and the point of the opposite vertex. Remember, the opposite vertex is the one you do not use to find the slope. If you find the slope of AB, you use C for the vertex. If you use AC for the slope, you use B for the vertex. If you use BC for the slope, you use A for the vertex. So it's the one that's not used when you're finding the slope. And the fourth step is exactly the same as the other ones. Once you have y equals for both equations, you just set them equal to each other, solve for x, and then go back and find y to find the whole point of intersection. If you need any time to copy these down, remember you can always pause the video, write it down, and then move on to the next step. Okay, so let's look at our very first example. Our first example is going to be a centroid, and this is number 1 from part A of your worksheet. So our centroid is going to be of the triangle -6, 9. So -6, 9 is your first point P, 6, 1 is point Q, and -6, -7 is point R. When you do these, it's always beneficial to graph them first. So first thing you should always be doing is graphing them on a piece of graph paper, okay, so that you can visualize what's happening. And then you want to make sure when you're doing that you always use a ruler and you count carefully. If you count wrong, okay, you're going to make some silly mistakes. So if I graph my triangle, okay, he looks something like this. I have P, Q, and R. And he looks pretty good. We have a nice triangle. I've used a ruler, so all my lines are nice and straight. Okay, and the first thing I said I wanted to do, step 1 for a centroid, is to find the midpoint of two sides. So I'm going to use PR and PQ. You could use any ones you want, but I'm just going to use PR and PQ. So PR will be my first one. Remember, you want to label everything. So when I do midpoint, we'll call it PR. And then midpoint, QR. And again, you can use whichever ones you want. So first thing we do is we add our x's for our midpoint. So PR will be -6 plus -6 over 2. And y's would be 9 minus 7 plus -7 over 2, which will be -12 over 2 and 2 over 2. I'm sorry, I said PR or Q or P. Let's do QP. That was the one I said I was going to do. Okay, so then when we reduce this, this will be -6 and 1. And then QP will be -6 plus 6 over 2 and 9 plus 1 over 2, which gives me a result of 0, 5. Okay, so these are my midpoints. The first one is at -6, 1, and the second one is at 0, 5. So if I look at my graph, I can check and make sure that I'm on the right track. So -6, 1, I'll call the first one M, and the second one N. So -6, 1 would be point M, and 0, 5 would be point N. And if I look at those, they do both look like they're in the middle of my line. If you get a point that's off your line, that means you probably made a mistake. Go back and look at what you did. Okay, check your signs and things like that. So I have my nice picture. And remember, a median, a centroid is where the medians cross. I want to go from the midpoint to the opposite vertex. So for Q or PR, I want to connect it to Q. So there's my first median, and then I want to connect NR to get my second median. So for the next step, I wanted to find, okay, the equations of my two lines. So I want the equation of line RN and the equation of line QM. So RN is the first line, QNM is the second one. Okay, so I want to write down my points. R is from the top, -6, -7. And N is 0, 5. QM is going to be Q at 6, 1 and M at -6, 1. So when I find the equation of my line, I now have 2 points, just like I did for the first example, the second example from the last video. I had 2 points and I want to find the equation of a line. So for Rn, first thing I have to do is find my slope. So slope is 5 minus -7, subtract the y's, over 0 minus -6, subtract your x's, and I get 12 over 6, which is the same as 2. So that's my first slope. And I'll go and find the slope of QM also. Okay, subtract the y's, 1 minus 1, subtract the x's, 6 minus -6, this will be 0 over 12. Okay, and that reduces to 0. So now I have both slopes. The slope of Rn is 2, and the slope of QM is 0. So now I go ahead and I do my point slope form. And I say y minus y1, and I'm going to use x1, y1 right here because there's no negatives. You could use -6, -7, that's completely fine, but this one just looks a little bit easier. So I'll subtract 5 equals 2 times x minus x1, which is 0. So y minus 5 equals, remember I distribute, so this is 2x, and 2 times 0 is nothing, so I don't have to add it on there. And then add 5 both sides to get the y by itself. So y equals 2x plus 5. Okay, now I go to the other side and I say, okay, I'm going to use this point, x1, y1, because again, there's no negatives, so it's a little bit easier. Y minus y1, which is 1, equals 0 times x minus 6. When I distribute on this side, everything over there becomes 0, so y minus 1 equals 0, so y is equal to 1. Which is a pretty nice equation. So now I have y equals 2x plus 5. Here's line 1. Here's line 2. And I want to find out where they cross. So if I'm looking at my picture and I label it, this is y equals 1. Remember on your Regents exam when you had to label all those lines? This is y. You want to make sure that you know which line's which. 2x plus 5. And we want to know where they cross each other. We want to find our centroid, which is our intersection point. So in order to do that, we set the y's equal to each other. So I'm going to say 1 equals 2x plus 5. And this is just a substitution. Since the y's are the same, we can get rid of them and set them equal. So minus 5 here, if I do 5 minus 5 and 1 minus 5, I get -4 equals 2x. And x equals -2.